Good morning, students. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Python code for K nearest neighbor algorithm. Basic concepts of K nearest neighbor algorithm. 1. KNN is one of the simplest machine learning algorithms based on supervised learning technique. 2. It can be used for both regression and classification, but mostly used for classification problems. KNN is a non-parametric algorithm, which means it does not make any assumption on underlying data. It is also called a lazy learning algorithm because it does not learn from the training set immediately. Instead, it stores the data set, and at the time of classification, it performs an action on the data set. Lazy learners wait until the last minute before classifying the data point. They merely store the training dataset and waits until classification needs to perform. With the help of KNN, we can easily identify the category or class of a particular data point. Consider the below diagram. It is category A data. It is category B data. Here, a new data point is to be assigned to either cluster 1 or category 1 or category 2. For that, the KNN algorithm is to be applied. Here, K value 3 means for the given data point. Here, we need to consider the given data point as the center. We need to draw a circle in such a way that 3 data points will be covered in that circle. Here, the 3 data points are associated with category A and category B. If the value of k is equal to 5, the circle is drawn and the radius is adjusted in such a way that 5 data points will be covered, and in such a way that the 5 data points are associated with category A and category B, and the cluster to which the more number of data points are present in the circle, for that category, the new data point will be assigned. That is the main concept of K nearest neighbor algorithm. And here, always the value of K, better to choose the value of K as a odd number. K nearest neighbor algorithm steps. Step 1, select the number of K neighbors. Step 2, calculate the Euclidean distance of K number of neighbors. Step 3, take the nearest neighbors as per the Euclidean distance. Step 4, among these K neighbors, count the number of data points in each category. Step 5, assign the new data point to that category for which the number of neighbors is maximum. Step 6, our model is ready. Basic syntax of classifier. The Python code for classification, few classification algorithms are discussed in earlier lecture. Slightly you can modify uh, the classifier code associated with KNN algorithm to change your algorithm from the previous classification algorithm to the KNN classifier. For that, you need to import the supporting library in which the KNN classifier is present. It is the KNN classifier which is available in sklearn dot neighbors. You need to import the library as from sklearn dot neighbors import k neighbors classifier, k neighbors classifier, and here uh, the classifier is assigned to a user defined variable clf. The change with the previous algorithms is here uh, within the brackets the number of neighboring values are given. The k values are to be assigned within the bracket. uh, the syntax is within the bracket n underscore neighbors is equal to, if the value of k is 3 then it is equal to 3. If the value of k is 5 then here you need to assign 5. And the next is train the model with the help of fit function. These coding lines are to be modified to convert the code of the previous discussed algorithms like SVM logistic regression and name-based algorithm to convert the classifier code for k nearest neighbor algorithm. Python code, import library, load data. For any classifier algorithm, you need to follow the steps. Step number 1, import supporting libraries. Load or define data. Here, the iris dataset is loaded to variable iris. The dataset is available in sklearn library. This can be imported as datasets dot load underscore iris. It will load the CSV file to the CSV file which is available in sklearn datasets. It will be loaded to the variable iris. The next is divide data into input and output variables. The input variables are called features. The output variables are called target. Uh, for the iris dataset, the features are sepal length, sepal width, petal length, and petal width. The target is the type of species it is Setosa, Virginica, and versicolor. The next step is split the data into testing and training sets. Train the model. Fifth step, with the fit function. The last step is prediction. While writing the code for any classification algorithm, you can follow these steps. Here, iris dot target underscore names. It is the output variable assigned to variable y. The target names are Setosa, versicolor, and Virginica. The feature names can be displayed with the help of print command. Print iris dot features feature underscore names. The features or input variables are sepal length, sepal width, petal length, and petal width. And with the help of data.head, it will display the top 5 data elements. And the tail will display the bottom 5 data elements, including features and target. Setosa, Virginica, versicolor means 0, 1, and 2. assign targets. And here the next step is split the data into training and testing set with the help of supporting library and the syntax given here. And to divide the data into input and output features and targets, this can be done with the syntax, or you can use .ilog function. The training can be done with the help of syntax x underscore train, x underscore test, y underscore train, y underscore test is equal to train underscore test underscore split of x feature, y target, test underscore size is equal to 30. And here you can incorporate a random underscore state is equal to 0. A KNN classifier defined below. Uh, it is a supporting library which is used to import the KNN classifier as from sklearn.neighbors import kneighbors classifier, and this classifier will be assigned to a user defined variable CLF. Within the brackets we need to specify the number of k values. Here the value of k is equal to 3, then you have to mention k equal to 3. And the next step is train the model with the help of fit function. The syntax is clf dot fit x underscore train y underscore train. The model will be trained based on the training data set. And the next is predicting the output. And here you can calculate the model accuracy. The accuracy of the model is true positive, true negative divided by true positive plus true negative plus false positive plus false negative. And the syntax to display the accuracy of the model is matrix dot accuracy underscore score y underscore test and x y underscore predict. The supporting library is the matrix method which is available in sklearn library. And to display the output or to classify the data for the sepal length, sepal width, petal width, the type of output you will get here for the given values. The output is setosa, and for these values the KNN classifier classified it as versicolor, and for these values it is Verzenica. For different values which are available in data set, or you can give the new data values which are associated with the data sets. You can classify or predict the data, or what is the type of species it is. You can classify the data. Thank you. We will meet with the next lecture.